Homework Solution 2.3. A series AC circuit exhibits a total impedance of 10 kiloohms with a phase shift of 65. Draw the impedance triangle and determine both the real and reactive components of the load, assuming that the load is lagging. What quadrant would the current phasor for the circuit be in? So, major challenge in this question is decoding what the problem says. We are told that a series circuit exhibits a total impedance of 10 kiloohms. That is saying total circuit impedance for the magnitude of Z is equal to 10 kiloohms. We're then told it's a phase shift of 65 degrees. That means phi sub Z is equal to 65 degrees. We're asked to find the impedance triangle. That means we need to know R and X for the circuit. And we want to know what quadrant that is in the real complex plane. So the solution is that Z is equal to R plus JX. That can also be written as magnitude of Z at an angle of phi sub Z. So those are two equivalent ways to write an impedance vector, either in rectangular or polar form here. And the relationship between these two forms is that magnitude of Z cosine of the impedance angle is equal to R, and the magnitude of Z sine of the impedance angle is equal to X. So we can say that R is equal to 10 e to the third times the cosine of 65 degrees, and we know that X is equal to 10 e to the third times the sine of 65 degrees. So this is 4.23K, and this is equal to 9.06K. So if we were to write Z in its rectangular form, we will get 4.23 plus J 9.06 kiloohms. We can go ahead and draw that as a impedance triangle. We know that the real portion lies on the x-axis, so that's 4.23 kiloohms. We know that we got a positive value for the impedance. That means this is an inductive impedance or an inductive reactance, so that's 9.06 kiloohms, and then this is 10 here with an angle of 65 degrees. We know that the load is lagging. Oh, that's actually what told us this was inductive. Load is lagging, so by definition this is a plus sign by lagging. That also puts it in the first, the impedance vectors in the first quadrant. What quadrant would the current phasor be in? Remember that the current always has the opposite angle to the impedance vector. That means this current is going to be at negative 65. So I, no matter what the voltage is well, taking voltage as the reference, I is going to be in the fourth quadrant, right? It's going to be a lagging current. Lagging currents occur in the fourth quadrant.